All right, now we're going to take a look at percent composition, one of the uses for formula mass calculations. We'll get into the other one next week. As you can see, this is in your textbook in Chapter 7, so if you're interested in checking out some more details on that, you can go there. Let's just go ahead and get started. Percent composition is kind of what it sounds like. It's the percentage of each element in a compound, but it is the percentage by mass. If you need a formula for that, percent composition is the mass of an element divided by the total mass of the compound times 100 to convert it to a percentage. All right, so what does a percent composition formula problem look like? Problem is usually as simple as someone saying find the percent composition of, and in this case it's copper 1 sulfide. So that means the percentage by mass of both of the elements in that compound. So the percent copper, so if I'm looking for the percent of copper in that compound, I need to figure out what's the mass of copper in that compound. So I'm going to take the molar mass of copper times 2 to get 127.1 grams of copper. Then I'm going to look up, and then I'm going to calculate the total mass of copper 1 sulfide. So the mass of 2 coppers plus 1 sulfur is 159.17 grams. So if you're doing those formula mass calculations and you know you're going to be doing a percent composition, it can be kind of useful to have all your work written out so you can get to these intermediate values like the mass of 2 coppers without having to go through the calculation every time. And then you just divide in your calculator, multiply by 100, and you wind up with 79.85% of copper. Okay, there's 2 ways, well, there's at least 2 ways to calculate the percentage of sulfur in the compound. The first way is to do exactly what you did for the percentage of copper. Take the mass of sulfur in the compound. There's only 1 sulfur, so that mass is there. The mass of the total compound is the same, 159.17. Do the math, and I wind up with 20.15% sulfur. Excuse me. All right, so a lot of you might have said, well, heck, I can just get that number by taking 100% and subtracting the 79.85% from that, and I'm going to get the same thing, which is exactly true. You should get the same number. I honestly usually calculate both of them anyway, and I add those 2 numbers together and make sure it's really close to 100%, kind of as a check on my work, but you can certainly do either way for calculating the percent composition of a compound. All right, percent composition problems can also come in different variations. Let's say someone's taken a compound, a chunk of rock, shall we say, and determined that 28 grams of that chunk of rock is iron and 8 grams is oxygen. So that's pretty easy to determine percent composition. You just take the mass of the iron in the compound and divide it by the total mass of the compound, which is 28 plus the 8 grams, and you wind up with 78% iron. You do the same thing for oxygen, so you start with 8 grams of oxygen divided by the total mass of the compound to get 22% oxygen. This helps you to do a couple of things if you have this kind of problem. One, you can figure out what the formula of the compound is. We'll go over how to do that next week. You can also use it to determine the identity of the kind of ore and stuff by just looking at the percentages. All right, let's say you had a 38-gram sample of copper 1 sulfide, same compound we looked at in the first example, and you want to figure out how many grams of copper you're actually going to get from a 38-gram sample of copper 1 sulfide. And from the previous work, we know that 79.852% of copper 1 sulfide is actually copper. So I just take the percentage, I convert it to its decimal form to do math with, take my 38 grams of copper 1 sulfide times the percentage, and I can see that I could get 30.3 grams of copper from that kind of sample of copper 1 sulfide. Last variation on this percent composition problem is looking at the percentage of water in a type of ionic compound that is referred to as a hydrate. Hydrates have the word hydrate as part of their name. The prefixes tell you how many waters are incorporated in the chemical formula. And the chemical formula looks kind of weird. This little dot here is not a multiplication sign. It just means that calcium chloride is complexed with 2 waters, the ratio of 2 waters for every 1 formula unit of calcium chloride. So if you want to find out how much of that particular ionic compound is actually water, so the percentage of water, first you have to determine the mass of water and multiply that by 2. That turns out to be 36.04 grams. And the mass of the whole thing, which is the mass of calcium chloride plus the mass of those 2 waters, turns out to be 147.02 grams. The percent composition calculation is exactly as before. The part divided by the whole times 100 means that your calcium chloride dihydrate is 24.51% water, or just about a quarter of the compound is water by mass. All right, the problems, I'm not going to go over how to do the problems. They're from your textbook. There's a set of problems in the back, but I've copied them out exactly. If you want to refer to them, you can take a look at them there. When it says here to determine the percent composition, it means for each element in the compound. So you're going to do it for sodium, carbon, and oxygen, for the sodium oxalate, and so forth. There's a second set of problems after that. So these problems that are at the end of the PowerPoint, which I will post separate from the video, will be part of the assignment for this week.